Hello and welcome to the latest episode of Rivada Space Network's Watch This Space. I'm Brian Carney and my guest on this episode is Commander Nick Goddard. Welcome to the show, Nick. How are you doing?
Doing great, sir, and looking forward to the discussion today about security. It's a big deal, and I think most people don't pay attention to it as much as they should.
All right. So why don't you start by telling us what you do and what your job is?
So, my name is Commander Nick Goddard. I'm the Director of Operations at Navy Cyber Defense Operations Command. I work for Vice Admiral Clapperton and Fleet Cyber Command, and ultimately for General Hawk underneath the U.S. Cyber Command. My job is to defend the DoD Information Network Navy, so all things unclassified and classified for the U.S. Navy, both afloat networks and terrestrial ashore networks.
So when you say you're defending those networks, can you tell us a little bit about what the threats are that you face? What what does your job look like?
Sure. So, currently we are evolving how we do defense. So, as the new technology is modernized the landscape, specifically on the commercial side, generally speaking, the Department of Defense lags in some of the modernization efforts. And so, what we're trying to do is take some of the newer tools and integrate them into our current infrastructure to see how best we can either increase visibility or harden networks when it comes down to securing them with new tools. What we find the biggest challenges are, I'll talk about the adversary threat later, but internally, the technical debt has always been part of the challenge for a large organization such as us. And on the Navy side, we have different schedules for both technology refresh on shipboard systems versus ashore systems.
Right.
And generally speaking, the IT systems at most organizations aren't thought about first and foremost. Specifically, when it comes to DoD, we talk about weapon systems, we talk about really important things. But what we don't realize is they're all back-ended by really good IT or really bad IT, depending upon what scenario we're talking about. And
Right.
so, from a defensive landscape, it's really understanding what our attack surface looks like. If you had to ask me in this position 10 years ago, all the logical devices and connections we had in the Navy, that would be an impossible thing to know. And
Okay.
so, with the tools that we've invested in over the last several years with some cloud-based tools and infrastructure, we've been able to illuminate some of that shadow IT and some of those networks that were either stood up for a bespoke reason or were forgotten about as they were still connected to the open internet. And
Right.
so we've been able to cut down on the visibility challenges by just adopting modernized tools. And it's ensuring that the entire Navy ecosystem compensates by telling them hardware has to be modern, meaning you need to take some of these more advanced tools. Otherwise, you're not going to get the defense baked in. And then we're going to be constantly playing what we call incident response after there's a known breach.
So I don't want you to say anything that compromises national security, obviously, but how many breaches are we talking about? What is the frequency with which you guys are dealing with that kind of thing?
So I'd say 10 to 12 large breaches per year, not just from nation states, just from other threats that are adjacent to nation states that are hard to actually characterize. Some of the challenges you run into is as new technology is integrated, the adversary modifies itself very quickly. And we spend a lot of time trying to chase the threat actors as they're moving either adjacent at the perimeter or sometimes inside our networks. As an example, with our cloud-based infrastructure, we currently look at about 8.6 billion unique events every 24 hours. And
Wow.
so of those billion, we have to sort through using some machine learning and AI tools that are available in the commercial industry that we've been using. We knock that down to anywhere about 100 to 50 events that my team investigates to ensure that there is not an actual breach. Maybe it's a misconfiguration. Maybe it's a software load that is acting in a way that it's not supposed to just because of a conflict with hardware and software. We spend a lot of time chasing that in addition to the intelligence-driven threat that we have access to here while we're trying to outmaneuver some of our adversaries as they gain more capability as well.
Got it. So when you said that they weren't all nation states, can you say anything about the kinds of adversaries that you're talking about?
Yeah, so we have some people call it insider threat. Some people just call it technology uninformed personnel, clicking on things, installing things just to make their local networks more effective. And unfortunately, they introduce vulnerabilities by trying to make their lives easier and more effective. Because one thing that we run into a lot, at least on a largely bureaucratic system, is efficiency. We're not designed to be efficient from the very beginning. So what we end up doing is our folks are usually overtasked and under-resourced. So we automate a lot of processes. And what that ends up doing is when you automate one process, there's dependencies that people and personnel don't necessarily fully understand, second and third order effects. So we don't necessarily see it either until there is a problem that was unintentionally introduced. Although everything on a configuration on a layer 3 routing device is perfect, everything else that is below it in the physical, down to the physical layer, may not be configured appropriately. And so we won't see it until it hits a layer 3 sensor. So we are trying to push, our sensor coverage further out so we can sense the domain both on the wire, over the air, and through fiber optic cables long before an adversary has the ability to touch our networks. So it's not just malicious actors, it's well-meaning, well-intentioned personnel trying to do their day-to-day job. And they unintentionally create conflicts for the defenders inside the ecosystem. And so we spend a lot of our time trying to ensure that it wasn't malicious in nature. We may not be able to explain it, but we can understand that it's not malicious, and we need to figure out how to better architect that network going forward.
Right. So does this get into this idea of zero trust? I wanted to ask you what zero trust means to you, and just if you can explain that for a lay audience, because it's a buzzword, I know, in the cyber industry, but maybe a lot of people don't know what that means.
No, totally agree. I think zero trust for most folks is unobtainium, meaning, I would have to essentially burn down my entire network and build it up from scratch.
Okay.
And for us, a portion of that is occurring, meaning zero trust for us is we assume breach. So the adversary, whether it's a criminal malicious actor, whether it's a nation state, or whether it's a script kiddie, is looking for something. Sometimes they're just probing interfaces and seeing how far they can get. When it comes to the defense in depth model that we currently use and have been using for quite some time, a trust but verify, that doesn't work when your modernization is not homogeneous across the board. So we have different terrain. We have over 200 networks that we have to secure and defend, and not all of them are the same types of networks, not all of them the same size. They have different technology stacks included in them. And so the only way we have the ability to maneuver in such a way from a risk standpoint is to not just adopt zero trust as we've been directed to by DoD CIO, but actually implement zero trust in each one of those networks. Meaning that I'm going to assume a breach, so every connection by default is not trusted. So there's a continuous authentication and a continuous monitoring burden that typically wasn't a part of normal network schemes. So for us, in order for me to see a threat, I actually have to see the threat. And so really it comes down to not just logging, but how each transaction is occurring with things like identity, as an example. Identity, kernel level access, layer 3 firewalls, all of them work together in harmony. And although the DoD and NIST have pushed out information about zero trust, there's no DoD zero trust task force that says you are zero trust certified.
Right.
So what we're attempting to do is do the best we can by implementing the target activities that DoD-CIO has identified, and actually then red team, blue team. So we do purple teaming, and we're getting better at it, and identifying if it says it's zero trust, let's actually go prove it. And I'll have my Navy red team or another Navy red team or an NSA red team go after that network to ensure that it's not just words or tools attached to the 7 pillars. And it's a lot more than PowerPoint deep, which I think is something that separated the Navy from the other branches of services, where we are diving really hard on zero trust to include not just in the terrestrial domain on typical networks, but on things like the Rivada space network. How do we push forward zero trust to not just one industry, but to all industries to ensure things like intellectual property, to ensure things like banking, billing, personally identifiable information, all the things that we don't want to walk away. Everything is precious, and what we're trying to defend now is not the network, it's the data in the network, and which is why zero trust is so important for the DoD and the Department of Navy going forward.
Okay, so you mentioned space, and as you know, Rivada Space Networks, we're building a satellite network. We say it's not just a constellation, but it's an orbital network, and the idea is to bring end-to-end connectivity that doesn't touch the terrestrial internet or subsea fiber or any of that. And what does that kind of capability mean for a customer like the Navy? What is the appeal there, if there is one? And can you talk about that for a second?
Yeah, absolutely. So we have the way we've been architected over the last 40 years is relying on existing infrastructure because the Navy's always been mobile, right? We can't drag an Ethernet cable out in the middle of the ocean. So our environment is a little bit more unique. The challenge is we've been using MilSatcom for a while, and commercial SATCOM has now changed the ability for us to communicate rapidly and push data that is really important to the edge much faster. The challenge that comes with that is when you look at untrusted connections, things you don't control, that's
Right.
when you start running into attack surface mitigation, or the fact that we can't even actually see all of the attack surface because we have another organization that is deciding on our route and where it's going. And so what we're trying to do is implement zero trust with Rivada and other network providers in such a way that not just we control the route, but we understand what's happening in that ecosystem through zero trust. And if there is a challenge for us, we have the ability to make a rapid decision, not over hours, but over seconds, to change the route directly to the edge and ensure the warfighter does not lose a gap in C2, command and control, or the ability to actually receive information that may or may not be combat related in a peacetime environment. So, as an example, somebody that has an injury on an aircraft carrier that requires help from a surgeon that they may not have the expertise on board, the ability to actually have low latency secure comms ensures that we can talk to doctors around the world to save someone's life. So it's not just about a wartime context, it's about a peacetime as well. And the more we can remove out of the untrusted connections and the more we can remove latency, the better it is we can ensure the security of the global commons.
Right. And so in untrusted connections, you're including, terrestrial fiber networks, subsea cables, all that stuff that a lot of satellite networks, and maybe a lot of people don't realize this, right? But a lot of satellite networks, I know you know this, they go up and then they go right back down to a gateway somewhere, and then they travel over God knows what to their final destination. And from your perspective, the problem there is that increases the attack surface and the vulnerability of that kind of chain of communication, right?
Yes, and it requires all those third parties to work together in a common reference. And that's not always the case with several business verticals that have nothing to do with defense. And so commercial telcos and other mobile telcos, they have their own architecture to ensure that they're delivering the best product to their customers. Well, when we ride some of those cables, we or other communication paths, we rely on that business service level agreement to deliver. That doesn't
Right.
work the same for us. And so what we're looking at is how do we take a look at transport in a new way? Because we're moving into sensing the physical layer. And the less that we have to censor, the less that we have to deploy, one, decreases cost for us, and two, allows us to make much more informed decisions about how we use that transport path and not just why we have to use it, but about there are alternate options that allow us flexibility no matter what type of environment we're talking about.
Okay, and you've talked a bunch about layer 2, layer 3. When you and I have spoken before, you've talked about the problems with, I think you called it layer 8, which are the people, right? Can you just explain what that means when you refer to layer 2 versus layer 3 again in a way that maybe mortals can understand, because maybe a
Yeah,
lot
so
of people don't know these
layer
terms.
three, typically like on your networking layer, right? That's where your routing appliance sits that most people are generally familiar with. Well, as you go through the OSI model, you get to the top. So you have the application layer, which is 7. I call layer 8 that's the human layer. That's when everyone gets to interact with the data, and that's where social engineering. That's where lots of other opportunities from a targeting standpoint Because most times you're not dealing with a network engineer on the other side of a keyboard. You're trying to, inculcate from a cultural standpoint, what you do matters every day you interact on your computer. And it's not just about spear phishing. Sure, that's important. That's step one, but it's about how you connect, what you do with your passwords. Multi-factor is critically important. Writing your password down and using it for 1,000 different services.
Right.
Password spraying from an adversary happens daily, and getting access to those networks, specifically into a DoD network, is a real thing for us because we have complex requirements for some of these systems, but
Right.
very insufficient access control mechanisms that are still, unfortunately, username and password. And so
Yeah.
it's not just about building the best technology out there, because the hyperscalers, the Googles of the world, Microsoft of the world, and the Amazons of the world are delivering technology faster than most folks can integrate that into their technical stack, or even into the network engineering level, down to a human going, I have this new feature, what do I do with it?
Right.
And so you end up running into challenges with people understanding how to use those tools. And then you run into other problems that have nothing to do with security, but absolutely will make your system more vulnerable. And that's where we spend a lot of time on the culture side in engaging with the end user each time to say, look, this is a new feature. However, it doesn't come without its pitfalls if you don't understand how to use it.
Yeah, sure. I mean, my mother fortunately doesn't work for the Navy, but sorry, Mom, to tell your secrets, but she's still got a bunch of Post-its stuck to her computer monitor, I'm pretty sure, and that there might be some pet names involved. It's a classic story, and obviously there's only so much you can do about people who are resistant to those things. But I guess you also have to make it easy for them, right, to be compliant and to be secure about that stuff and
Yeah, it's
more
a risk-based.
technologies.
Yeah, it's a risk-based decision, right? The most secure network is the one that is turned off. And so you have to balance that risk with availability. I think the challenge is most folks don't understand that risk. And we've done a poor job in the technology industry explaining what that risk truly is, and just saying, hey, buy this product, you'll be okay. So what we're doing on the Navy side is looking at technologies that give us, one, the ability to integrate best of breed, while also having a partner that is invested in the same way we are when it comes to security. So secure by default and secure by design are great concepts, but if you have a network architecture that's 40 years old, it's really hard to build those type of safeguards in that old network. You have to do it piecemeal. And generally
Right.
speaking, most folks don't have the funding for it. So what is the best way to implement zero trust in phases in such a way that you don't lose your primary mission on, remaining connected, while getting the best security infrastructure and ecosystem that you can, without trying to tell everyone, I need you to log off. We're going to build this brand new bespoke network that will take years to build. And then when we turn it on, it's already outdated. So we are becoming more fluid and flexible about how we adapt technology, and not just buying one widget to solve one problem on one network.
Right. And I know that one of the things that we're excited about this, the work we're doing with the Navy now, is that we are getting your input on making sure that our system meets your needs and does what the Navy and the rest of our customers need it to do to make it valuable and useful to you. And I hope you guys feel the same way about that.
No, like I said, we're looking forward to it. Both the RF engineering expertise that you guys are bringing along with our teams, and then our cyber defense and the way we envision the CSOC, the Cybersecurity Operations Center of the future, with my boss, Vice Admiral Clapperton, and Captain Sharon Pinder here. We're excited to go on this journey, so that way we can actually build something that is both beneficial, not just in the government space, but also in the commercial space. We don't want a bespoke government system that is the most secure ever, because I do banking just like everyone else. I have to pay the
Right.
water bill. I got to do every other thing just like every other human. And so it really matters when security is taken seriously across all the industries. And it's going to take a huge partnership for security going forward, and a leap of faith that not all vendors are bad. And vendors actually want to deliver capable, secure technologies while also making financial commitments that they can actually stand by. And a government being specific enough to tell you exactly what we need in order for us to conduct these new types of capability integrations going forward.
Yeah. Well, we really appreciate the work that we've been doing with you and the input that we're getting from the Navy and from the rest of our customers. And I thank you for coming on the show today and look forward to doing more of it. So thank you,
Absolutely. Thank you,
Commander.
sir.
All right.
Appreciate it.
This has been Watch This Space. Stay tuned. More to come. Have a great new year and a happy holiday to all our viewers. Thanks.